Great, we are live. Hey everyone, welcome back to another episode of This is Tech Talks. And today we have a really special guest, Alex, who is joining us. And don't be scared, he's actually wearing his glasses, very fancy glasses. I really liked it. And we have another our co-host, Deep, who is joining us today. Jay is unfortunately not able to join. So, hey Alex, hey Deep, thanks for joining again. How are you?
Hi,
Yeah, doing good.
Santosh.
Yeah,
All good here? Happy to be here, man.
Thank you for joining, Alex, and thank you, Deep. Thanks again for
yeah. Thank
joining.
you.
So today we will be talking about Jina.AI. So I have, of course, I heard a lot about Jina.AI and saw the website. There are some. It's related to machine learning, and I'm not an pro in, of course, machine learning and all this chatbots and everything. So we'll be, of course, I think we will get a lot to learn from Alex. So Alex, before we move ahead, would you like to introduce yourself first?
Sure. Well, first up, likewise, I know very little about machine learning, and I don't really need to know much about machine learning to build cool AI powered stuff with Gina's ecosystem. I'm the developer relations lead, really heading up the developer experience side here at Gina. So, if you're unfamiliar with developer relations, it's like the engineers do all the hard work, and we make it glamorous to the community. And we make people want to use our cool stuff. Yeah, I'm based here in Berlin. I'm pretty active on Twitter. Uh, yep. Wherever I'm pointing to Santosh, and he has my Twitter background.
Yeah.
I do swear a bit, so don't follow me if you don't like that kind of thing.
Great. So, Alex, let's talk a little bit about Gina AI. So, what is Gina AI?
So, Gina is a startup based out of Berlin. We've got offices in, well, Berlin, of course, and Shenzhen and Beijing. And we're all about neural search. So, how do you use AI to build search engines and everything that goes along with that? Everything we do at the moment is open source. We're madly passionate about it. The founder of Gina, Hans Xiao, he's the same guy who did Fashion MNIST and Bertha's service. So if you're in data science, you've probably heard of those. Pretty cool projects. And now Gina's new projects are even cooler.
We'll, of course, talk about it as well. Great. So, Alex, so we are going to talk about how to turn unstructured data into actionable insights. So, do you have some presentation which you want to present, or should I go ahead and ask the questions? How you want to do it?
Yeah, sure. I can give a quick talk, quick
Yeah.
presentation.
Cool.
I'll share my screen. Where are we? Cool. All right. So first up, before we dive deep, let's just talk about what unstructured data is and what structured data is.
Can you
So,
just zoom in a little bit? I think
yeah,
because
of course, yeah.
yeah, we are live. So, yeah, this is
Yes.
perfect. Yep.
So when we're talking about unstructured data, first of all, we have to think about structured data. And an example of structured data might be a database or a spreadsheet. In this case, this is a classic data set used in machine learning. It's the Titanic data set. So this is the roster of all the passengers aboard the Titanic. So we've got things like name, sex, age, SIBSIP. I don't know what that means. Some of these I don't know what the field name means, but you can see it's all very structured. It's all in a table. Most of the fields are populated. Sometimes there's data missing, but you can see it has structure going on. This stuff is traditionally quite easy to analyze using true machine learning as opposed to deep learning or statistical methods. But when you come to things like unstructured data, yeah, you need some kind of deep learning to go with. One of the classic data sets for unstructured data, well, an example of unstructured data might be an image. For example, an image from the classic iris data set. So you and me, we can see green grass in the background. We can see a purple flower. I wouldn't know it's an iris unless it was specifically being told to me. But as humans, we can make structure of that. But to a machine, it's just a bunch of pixels. They don't. A machine out of the box can't understand this in the same way that it would the Titanic data set. So Bean is all about building search engines for this kind of unstructured data. And of course, I'm not just talking about flowers, because that's not much of a business model. But unstructured data covers all kinds of stuff. Free-form text, if you read a book, chances are it's unstructured text. Like Hamlet, Romeo and Juliet. There's no formal structure to it. Yeah, I guess you got chapters, you got lines, but that's as far as it goes. When you come down to images, you've just got lines of colored pixels. And then video, audio, things like DNA sequences, 3D meshes, they're all what we would consider unstructured data. So that brings me on to neural search. So I'm going to talk about building search engines for this kind of unstructured data using AI, because that really is the best way to do it. I would say that. And yeah, I'll open up a notebook as well. We can go through some code samples really quickly to show you how you can do it. And hey, kids, you can follow along at home in your web browser. We'll post the link to that soon. But first, the boring presentation bit. Yeah. So what is neural search and why should I give a damn? So we've got a content warning. There are going to be some animals ahead, some of them not so cute. So I've already given my spiel. You all know who I am, the man with the silly glasses. We're going to cover the basics of neural search. We'll build a little application. It's quite high level, but if you have questions, I'm happy to go into the weeds and dig in a bit more. Jina.AI, I've been over that. At Jina, we make a whole bunch of different products, all related to neural search. So Docker.AI is, if you're a data scientist working with unstructured data, Docker.AI, we're here to help you do that. You can think of it like Pandas or NumPy, but for unstructured data. I hope some of you are familiar with Python, because I will be dropping a few Python-y words around. You can build a very basic search engine just using Docker.AI, and that's what we'll do today. If you want to scale that up and run it in production on the cloud and have web-based interfaces, you'd want to use Jina, which radically extends Docker.AI. As I said, I don't know much about writing machine learning algorithms, and that's where Jina Hub comes in. Jina Hub is like an app store of all the different machine learning models and other little utilities that you would need when you're building a search engine. Things like, if you're taking a whole bunch of text, you want to break that down into sentences, because you would want to search for something on a sentence level. Or converting it to something the deep learning model can understand instead of just plain text. We have fine-tuner, because a lot of the stuff on Jina Hub, it uses pre-trained models. And the pre-trained models are usually, they'll get you 90% of the way there. But if you're doing image recognition, the model you use will probably be just as good for recognizing chest x-rays or fashion items or teapots. Very general purpose, so you may want to fine-tune it. Clip as service? Well, Clip is a really popular deep learning model for understanding images. So if you need to use that, that's there for you. Jina now lets you build your own search engine with just one line on your terminal. If we have time, I'll give you a quick demo. It's brand new. And JCloud, it lets you deploy and manage stuff on the cloud. That's like super new, just a few days ago. But now, what the flip is neural search anyway? I keep throwing the term around. What's it even mean? Well, first of all, what is search? Because normally when we think search, we're just thinking a text box on your screen, bang, 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 type stuff in, hit enter, pages of results come back, right?
Yep.
I mean, yeah, that is search, but search can be so much more.
Mhm.
Because neural search is search plus neural networks. And let's look at what it can do. So let's say you want to build the next Amazon, and you want your customers to be able to take a picture of their favorite shoes and find similar shoes. Now, all of these pictures are, of course, unstructured data. Traditional
Mhm.
search engine frameworks don't cope too well with that, but we specialize in unstructured search. So you could do that. Amazon already have a feature for that, but that's for Amazon to use. We let mere mortals use it in their own code without, I should say, having to write any of this machine learning code. We've got an example of that, and I'll go over the example a little bit. So you can search for fashion items based on a text input, or you can upload an image. You can filter it by all these different criteria. Or even a chatbot is a kind of search. When you use Google, you're getting back pages and pages of results, but a chatbot is just returning one result and then waiting for your next query based on that. So it is also a search problem. Other kinds of unstructured data, oh, yes, of course. We have an example here as well. Other kinds of unstructured data, you might have a big library of PDFs and you want to search through that. You might want to build the next Shazam and be able to search all of Beyonce's music and find similar songs. Or you might want to find similar videos. In short, it's all about similarity search. Traditional search is similarity search, but generally only with text and structured data. With Jina, you can do similarity search for all kinds of data. If there's a deep learning model that can understand that kind of thing, you can build a search engine for it. So neural search uses deep learning models to create and compare embeddings to find similar things. And we're going to go over this now a little bit. So if you don't know any of these words, don't worry too much. You will in 5 minutes time, let's say. So fair warning, it's animal o'clock, people. So we're going to look at some pictures. So, okay, pop quiz. What have these little pictures got in common?
They're animals.
They're
Pets.
animals, yeah, pets,
And
yeah,
pets. Yeah.
and they're all really cute, right?
Yeah, of
Yeah.
course.
Yeah, of course.
And what's the difference between them?
Colors.
Colors, or if we could group them into two things.
Cats and dogs.
Cats and dogs, puppies and kittens, yeah.
Yeah.
Okay, so the best thing what does everyone want to do with cute animals? We want to pet them, we want to hug them, we want to put them on a graph because we love mathematics even more than we love cute animals, right? So we've really only got one dimension because they're all animals, they're all cute. So we can really only say, are they cat or are they dog? So pretty basic graph. So far, so good. Let's look at some more pictures. Yeah. So again, we've got cats at the top and we've got dogs at the bottom. And I have been informed that the one on the bottom right is a dog. Yeah, it'll haunt your nightmares, man. So where would we put these on the graph? Well, it would make sense to add another axis, right? So we've got cattiness and dogginess and And this is the time for some definitions. So we call these axes dimensions. And each point on the graph is an embedding. Because we have two dimensions, we've got an embedding consisting of two coordinates, tuple. So yeah, dimensionality of two. And we can call the whole thing the index. Now, let's get a new image, and we'll try to find something similar in our index. Now, where would this new picture fit? We all know, right?
Dog, yeah.
Right.
Yeah.
It's small and it's a dog.
Yeah.
And if we want to be more specific, we can see it's fluffy, it has white fur, 2 little eyes, a little black nose. So it fits closely with the other snowball dog. And yay, we found the closest match. We've done a similarity search. Now, yeah, it's just pictures of cats and dogs. How dumb do you think we are? Well, we were raised with pictures of cats and dogs, and maybe even real cats and dogs. We saw them on TV, in cartoons, we petted them. We know cats and dogs, and we can understand the dimensions of ugly, cute cat, dog. We've built a mental model ourselves and embedded the pictures into it based on their features. Now, an alien might be just as intelligent as we are, but if it's never seen a cat or a dog, it'll never know how to categorize these. And really, the way we're doing it is we're not thinking, is it cat or dog, or is it puppy or kitty? We're looking at a whole bunch of different factors when we do this, a whole bunch of different features, I should say. And that is how neural search is searching. It's extracting features, it's looking at the features of the other things in the index, and it's finding the closest match based on those features. Now, deep learning models, they use hundreds of dimensions. It's really difficult to show on a screen, and a lot of those dimensions are going to be things that we humans wouldn't really be able to understand. But yeah, the animals on a graph gives a good basic introduction. So who cares, right? Well, it's more than about fluffy animals. You can use similarity search in e-commerce or medical. It's like if you're a doctor and you see someone with a strange lung condition you don't recognize, you could try to match your x-rays with x-rays from other patients and see what comes up. Maybe patient X had a very rare thing and it was diagnosed, and now you found out a potential disease that your patient has. We've got people using Jina in online education, in chatbots, in a lot of real world fields. And you can search any kind of data: text, images, audio, video, 3D mesh, proteins. We've had examples of search engines built specifically for these things. I say any kind of data, but really you need a machine learning model that can understand that kind of data. So there are a lot of models out there. You could have something for Hindi or Bengali or English or Chinese. I'm not sure about Klingon, but I'm sure someone's trying it. One of our community members built a search engine for amino acid, which was really cool. Problem is, nobody knows how good the results are because nobody is a molecular biologist. But it does work. It returns results. We had a 3D mesh search engine, which was really cool. We need to get that redeployed. And we've got a whole bunch of these examples on, where is it? Examples.Jina.AI that you can play with. So a chatbot, image search, text image search, and another kind of image search. And all of these are open source. You can take the code, you can build whatever you like with it. Coming back to the deck. With Jina Hub, as I said before, I have very little background in machine learning, but I don't need that background. I can easily integrate all the latest cutting edge models like CLIP, like transformers, like SpaceSea. I don't even know how to say the GGISH or VGGISH audio classifier. But yeah, it's all there. You can integrate it with one line of code. And as I said before, a lot of these models are very general purpose, but you can fine tune it for your use case as well. Typically, deploying this stuff has been very difficult because cutting edge machine learning libraries evolve quickly, and getting different versions of different libraries working together is a bit of a nightmare. So we manage that, and we help you scale up as well by things like sharding, like replicas, like easy cloud deployment. And the advantages are of neural search that it actually understands the meaning of things instead of just looking for a string like DOG or PUPPY. It actually understands dog or puppy, works with all data types and loads of different plug-and-play modules. So yeah, Jina's mission, in short, we provide an open source neural search ecosystem, allowing anyone to search for information in all kinds of data, high availability and scalability. So you can take Jina, you can build your own search engine for whatever it is you want to search for. I don't recommend searching for the meaning of life or true love with Jina. We're not there yet, but hey, file a feature request. We'll see what we can do. Yeah, I thought I'd hidden just a few of these. So we can skip through quite a bit. So yeah, let's get building. So this isn't the thing we're going to be building, but we are going to build a simple fashion search engine. So we can do this in a notebook. If Jo is here, I hope she can share the link to it. Or rather, maybe I'll do that.
I think she won't be able to because YouTube actually filters out the links. So if you can,
okay.
if you
Yeah,
can
I
share it
can
in
share
private
it in
chat.
the private chat, yeah.
Yeah.
Cool. All right. So yeah. Here is the notebook. I'll bump up the font size. If you're not familiar with notebooks, they let you run Python, usually Python. You can run other stuff, but generally they let you run Python in your web browser. You don't have to install anything, and it's all highly interactive. You can edit code as you go along, so you don't have to run the whole thing. You can run chunks at a time. So we are going to build a simple fashion search engine with the Docker package. As I said, Docker is a data type for unstructured data. So things like text, image, audio, 3D mesh, yada, yada, yada. And it's really cool and really rather fun to play with. Right, back to the notebook. Bump up the font. Okay, we're going to build a simple search engine for fashion images. So we'll be able to upload an image of some clothing and then find similar matches in our data set. We've got a video of this with my colleague Jack as well. That's on YouTube. So if you search Jina fashion search, it should come up. We're going to set some basic variables to begin with. So we're going to tell it where to find our data. How many images do we want to index? Or how many images do we want to search through? Because, yeah, we don't want to search too many because that'll take quite a long time and we only have a short workshop. We're going to give it an input image, the image we search with. I'm going to change this to true because plotting embeddings is really pretty and can be quite useful. And we're going to give it a URL. So we'll get our fashion images from there. Next up, we'll install the Docker package using pip. Do I trust me? Yes, I do. Always takes a little while for these things to initialize. I really need to update this notebook because Docker is even faster now. But this notebook's a few months old. Okay, cool. So we're going to import stuff from Docker. So on this document, a document is the basic data type that we work with. As I said, it can be any kind of unstructured data. And we're going to have document array as well. So that lets us put documents together into something like a Python list, but with a few extra special features. Okay. We'll download the images. This is just using basic Python. Oh, of course, I forgot to initialize our config. There we go. Yeah, downloaded all of that. Now we Often in data science, loading data can be a bit of a pig, but we have a helper function, helper method, I should say, the from files. So we can just point it at our data path. We can say 1,000 docs as before, and it'll just generate a document array of all of these files. And we have 845. Now, I said maximum of 1,000, but yeah, we don't have 1,000 actually. And a really nice little feature of document array is we can preview all the images really quickly in a grid.
Oh,
So
nice.
we can't see them clearly, but we can see they're all kind of fashiony. We can see they're all different. When we're feeding data into a deep learning model, it has to be very consistent. It has to all be the same size, all of that stuff. So we're going to set up a function to pre-process our documents. It'll just do some stuff like load the document from a file to a tensor. It'll normalize it. It'll reshape it. And because it's a PyTorch model, you need to muck around with the axis. And now we can just apply that function en masse concurrently. We don't have to go for doc in docs, pre-proc doc. We can just go docs.apply, boom, which is much faster. Great. So we've got 845 docs. They've all got tensors, which is a big table of numbers that the computer can uses to represent an image. And we've got a URI. So that's the path to the file on disk. Now we're going to embed them, just like we did with the puppies and the kittens. So we're going to put them on the graph, so to speak. To do this, we're going to use the Torch Vision library. Yeah, installing requirements is the slow bit of every workshop. If I were running this on my own machine, all of these requirements will already be installed. But of course, if you use something like Google Colab, you can do lots of stuff. You can close your browser, you come back to it, and it's just reset itself, and all your state is gone.
Still, you have a better internet. You have a better internet at least.
Well, it's this is running on the Google servers, so not mine.
Okay.
So anyone can go to this URL and just follow along.
Okay.
This short, easy to remember URL. And I did run this notebook an hour ago, so it does definitely work. Okay, it should definitely work. I'm not going to tempt fate.
Yeah, I think meanwhile we can.
Oh, if you want a little Easter egg in Colab, this is really cute. Corgi mode and kitty mode. Let's enable that. Oh, more cute animals.
Yeah, so meanwhile we can take a question, Alex. So Vijay has this question: how is Jina.AI different from TensorFlow?
So TensorFlow is a very foundational library. It's a very low-level thing. So if you're building a deep learning model yourself, TensorFlow or PyTorch is a great way to do that. With Jina, we're doing a much higher level task, which is searching through your unstructured data. So you can build a model in TensorFlow and integrate that into your Jina search engine. Okay. Or you can use a whole bunch of other models straight out of the box. And Jina lets you scale things up, deploy to the cloud as well. Whereas TensorFlow and PyTorch, they're just about building the models. And then you have to use other libraries for other things. So I would say they're very different use cases.
Good.
Okay, so that's installed. I will just side. Okay, that is very distracting. Now I'll just turn these off. Okay, cool. Okay, my browser shifted to night mode. So yeah, we'll import it, and we're going to choose our model. So ResNet 50 is a really common model for image stuff. All right, we've got that. We're going to now embed the documents using the model. So we use the model, we feed in the documents, and then the model puts them on the graph that we were discussing. Embedding is always the most intensive thing. If you are using the full Jina package, you can use Jina Cloud to generate the embeddings on Jina's sandbox, and that's completely free. But since we're just doing something very basic and we're walking through all the steps, okay, we've done it. So that's 845 images put on the graph. And I say the graph like it's some abstract thing, but we can actually visualize it. Okay, let's actually open this in a new tab so we get the full experience. Okay, it takes a little while, but it's worth it.
So meanwhile, we can take another question, looks like. So there is another question from Vijay. So he says, do you have any use case for user behavior and click patterns on a web app, like integration with Google Analytics?
I would say that's very, very structured data. So it's not something we specialize in. Having said that, if you found the right model, you could easily build a pipeline using Jina to process that data and set up, say, a RESTful endpoint to search. But yeah, we really specialize in more unstructured data, similar to all of this. So these images. So the position on the graph is based on the embedding. So we fed it to ResNet. ResNet looked at all of them. It grouped them according to where it thinks they fit on the graph. And this is, well, it's a simplified version of the graph because, of course, ResNet 50, it says here it uses 1,000 dimensions, and we're on a 2-dimensional screen. I think we can zoom in as well. Can we zoom in? Maybe not. Oh yeah, there we go. So we can see all of these. I'm going to close this now and interrupt the runtime, because the one downside of generating this is it freezes everything else. So these all look like errors, but no big deal. Now we're going to get a query document that we're going to feed into our search engine, and then we can find similar things. So here it is. This guy with a white shirt and jeans, black hair. I mean, obviously, we're building a fashion search engine. We care about the white shirt. And I'll go into that a little bit more later. So we're going to put the query docs in a document array. That's because we were working with document arrays before. We're going to apply the same pre-processing. So that means we're comparing apples with apples. And now we're just going to, search. Oh, and sorry, of course, we have to create the embedding as well. So the way that the gene understands what it's looking at. Just like we were doing when we looked at the wet nose and cute little feet of the puppy. And now we're going to take our docs, all of the 845 images, and we're going to find the closest 9 matches with the query docs. Why 9? Because 9 looks nice in a grid, so I can show you easily in the notebook. Okay, that was done really quickly. So previously we did a lot of processing on the images, Now we want to reverse that. And yeah, these are the images we get back. So this guy was actually in our data set to begin with. So he is the top match.
Mm-hmm.
And then we've got other guys in shirts and one lady in a shirt. So it's finding shirts for sure. And they're not all the same, but it's not returning handbags or shoes or things like that. And considering we have under 1,000 images, we're not working with a huge data set. Now, as I said before, the model is looking at all the aspects of the image. So not just the shirt, but the hair, the face, the jeans, the hands. Obviously, we don't really want that if we're doing a fashion search engine in the real world. So we would want to do something like fine-tuning it specifically for fashion. And if we were doing this in the real world, we'd use the full Jina framework and Jina Hub executors to build the real-world fashion search engine. So this is a cute demo, but if you want to see the full thing or a much better demo, you can go to our multimodal fashion search.
Mm-hmm.
This is all completely open source. We've got a link to the repo. And with this, you can type shoes for a nice party, for example. And yeah, it'll return shoes for a nice party. So you can do image to text to image. And we're not actually searching any of this text. It's just returning that as metadata. It really is just looking at the images. Or we can say like funky t-shirt.
So Alex, Vijay has another question. So does this work with video, like searching an image from a video?
You can certainly do that. We don't have any examples right now, but we can definitely do that. So you would want to do that by breaking a video down into like separate frames. And then you upload an image, you find a video with that frame in the closest frame in all of the videos, and then you would return the parent video of that frame. Or you could just return the frame if you wanted.
Nice.
So yeah, we just search text. You can search by image as well. So, the front end, by the way, is built in Streamlit, which is a really nice Python framework. Okay, so let's search for black t-shirts. Yeah. So again, we're finding similar matches. This model hasn't been fine-tuned, but the data set doesn't really have so many people in it, so it's a bit, there's less to get confused by for the poor model.
Nice.
So the code is just here. We can look at the indexer. I wrote all of this. And so for building that index, it's under 100 lines of code to do the whole thing.
Wow.
Because we're using a lot of stuff from Jina Hub. So instead of like clipping coder is a state-of-the-art model for understanding images. I don't want to try to integrate that manually. So I just go, uses this thing from Jina Hub. And here we have Jina Hub. It's the app store for models and for utilities, I would say. So we have clip encoder. And yeah, boom, we can just use this in our code really easily. And we can even use it in Jina Sandbox. So you don't need to run it on your own machine. You can run it in the Jina cloud.
And it's for free.
For free, yes.
Cool.
So yeah. So in summary, you can build a search engine with just a few lines of code. As you saw, we didn't have that many lines in the notebook, and the full application is a few hundred, well, not even a few hundred lines. You can fine-tune the model for last mile performance, so we could improve it to make it specifically better for searching fashion. You can scale up for deployment on the cloud, on Kubernetes. You don't have to code a lot of the difficult stuff yourself. You can use building blocks. And then you have a search engine for any kind of unstructured data. If you want to learn more, you can go to learn.Jina.AI. And if you want to get in touch, join our community at slack.Jina.AI. Our engineers are really helpful, and they're always there to help answer questions.
Yes.
And
I'll post this link.
Perfect, yeah. And we have some events as well. So if you want to hear from the top minds in engineering, you can join us at our Engineering All Hands, which is a webinar format. Or if you want to know more about Jina for your use case, or you have questions about implementation, you can have a beer with the Jina team and just chat to us about that. And you can find all of this if you Google Jina Meetup. These are all online events, by the way. If you're in Berlin, we're looking at doing some offline events soon as well. Cool.
I'll surely visit.
Okay. Looking forward to it. Okay. So that's the talk.
Yeah, that's great. I mean, I'm really excited to try it out. So, last question for you, Alex. Anything you want to promote on the channel?
Wow, so many things. But I'll say the biggest, the newest, coolest thing we're doing is, let me share my screen again. Okay. We haven't officially announced this yet, but it's Jina now. So I showed you how to build a basic search engine in a few lines of code, and then even a quite advanced search engine in under 200 lines, I would say. But what if you want to do it with just one line of code? Now that sounds crazy, but Jina now lets you do that. You don't even have to, it's not even a line of Python code. It's simply a command on your terminal. Okay, so it's 2. You have to install it, and then you're on Jina Now Start, and you can choose to build an image search engine. You can search images with text or image, and you could search, say, fashion or chest x-rays or NFTs if you're into that. You can search art, cars, or your own data set as well. We've got an example of this on examples.Jina.AI, just here. I hope AWS isn't going to give me any grief. Looks good. So this is a search engine for art, and this has been fine-tuned based on the artistic style. So we could say Impressionism, and it'll bring back Impressionist paintings based on the keyword we gave it. So it's using this text, and it's looking for matching images, because we use the same model for text and images, in this case, clip. So it'll put text and images on the same graph. Most models don't do that. They'll only do text, or they'll only do images, or they'll only do audio. But clip is really powerful, can do all of them. Or you could also search by image. So we could give it this cubist, I guess, image, and we get similar things back. Maybe that's not cubist. I don't know. Terrible at that. I am a very uncultured person. So all of this is using clip under the hood. And so is this one. And yeah, you can build your own search engine for your kind of data using this. So if you really love ice cream, you can build your own ice cream search engine. I'd say, in terms of you actually doing stuff, it's just one line of code, choose a few options, boom, it'll open in your browser. If you're already building your own search engine, we've got another thing for you, which is Clip as Service. So I've been going on and on about Clip and how cool it is for searching images and text. Previously, if I wanted to build a search engine using Clip, I would have to do all the embedding on my own machine. And that is very computationally intensive. Like, it took hours and hours to index all the stuff for this search engine, several thousand images. But with Clip as Service, you can run Clip on a dedicated server with a GPU, and then you can just talk to that server via the API, send all the images there, and create the embeddings there. So you don't have to do all the compute on your own machine. And we've got an example server up. So yeah, you can use that. So if we go to examples, this is a really ugly website, by the way, because I designed it and my HTML and JavaScript sucks. I'm much better at Python. So Clip as Service, we've got the example server here. And just as an example usage, we've got the totally looks like data set. We can give it a text input, like happy potato baby. I don't know why I typed that. It's running. There we go. Okay, happy potatoes. And okay, it's a strange data set. So yeah, I gave it a weird, let's take out baby. I think that's confusing it a bit. But yeah, it's finding potatoes for sure from the totally looks like data set. And I guess this one is just happy food because it's a happy.
Nice. Thank you.
Yeah.
So, yeah, so thanks again, Alex, for joining. And it was really, I think I loved it. I mean, the examples and everything, and what you can do in less number of lines of code. That's really impressive. I will surely try this out. And thanks again, Deep, for joining us.
Yeah, thank you.
Yeah, and thanks again, everyone, all for to all the listeners as well. We will share this links in the video description. You can find out all the links which was shared here, and that's it for the day. And we will meet again next week with another episode, which is on replay.io. In case you're not aware, it's a tool where you can actually debug bugs, and very useful in case you are doing development. You can catch bugs early, and we will be joined by Cecilia, who is a developer advocate at replay.io. So thanks again for joining us, and see you next week. Bye bye.
Thanks, everyone.
Yeah,
Bye
bye
bye.
bye.